In this section, we will take a look at aspect-oriented programming, or AOP. We will learn what is AOP, what Spring provides to support the most popular implementation, which is AspectJ, and of course we will also take a look at built-in capabilities for AOP implemented within Spring Framework by itself. Okay, let's start. What is AOP, Aspect-Oriented Programming? AOP complements Object-Oriented Programming, or OOP, by providing another way of thinking of program structure. The key unit of modularity in OOP is the class, whereas in AOP the unit of modularity is the aspect. Aspects enable the modularization of concerns, such as a transaction management, which cut across multiple types and objects. One of the key components of Spring is the AOP framework. However, Spring does not rely or depend on AOP too heavy. However, AOP used in Spring Framework to provide us such as capability like transaction management and other declarative enterprise services. Let's start overviewing the concepts behind the AOP. First one is the aspect, which is a concern that cuts across multiple classes. Using aspects we can implement transaction management, cross-cutting capabilities like audit or logging, etc. Another interesting concept of AOP is a join point, which is actually the point during the execution of a program, such as the execution of a method or, for example, a handling of an exception. Advice is another point of AOP, which is an action taken by an aspect at a particular join point. Many AOP frameworks, including Spring, model an advice as an interceptor, maintaining a chain of interceptor around the join point. Next concept of AOP is a point cut, which is a predicate that matches join points. Advice usually is associated with the point cut expression and runs at any join point matched by the point cut. The concept of join points as matched by point cut expressions is central to AOP, and Spring uses AspectJ point cut expression language by default. Another concept is introduction, which is a declaring additional methods or fields on behalf of a type, and Spring AOP allows us to introduce new interfaces to any advised object. For example, we can use an introduction to make a bin, implement an isModified interface to simplify caching capabilities. Another concept is a target object, which is an object being advised by one or more aspects, also referred to as advised object. Since Spring AOP is implemented using runtime proxies, this object will always be a proxied object. And as soon as we already started talking about proxies, AOP proxies is one more concept of AOP, which is an object created by the AOP framework in order to implement the aspects contract. In Spring Framework, an AOP proxy will be implemented using JDK Dynamic Proxy or CGLib proxy. JDK Dynamic Proxy is used to implement AOP proxies for interfaces or classes based on interfaces. However, if our class is not implementing any interface, Spring cannot utilize JDK Dynamic Proxy to create a proxy for it. And in this case, Spring utilizes the CGLib library to implement a proxy for such cases. And last concept of AOP is weaving, which is linking aspects with other application types or objects to create an advised object. This can be done at a compile time, like in AspectJ case, or load time or runtime. Spring AOP, like other pure Java AOP frameworks, performs weaving at runtime. Let's take a look at types of advice we can leverage in our applications. Before advice, is a type of advice we can use to implement some logic before method will be executed. After returning advice is an advice that can be used to perform some logic after method will be executed. But in this case, if exception will be thrown, our advice won't be executed. For this type of advice, we can leverage after throwing advice. And this will be executed after exception will be thrown by the method. And there is one more type of advice which can be leveraged to implement some logic where the method exits successfully or by throwing an exception. And one more type of advice is around advice, which can be used to implement some logic before and after method execution. And around advice is the most general kind of advice. Since Spring AOP provides a full range of advice types, we can recommend that we use at least powerful advice types that can implement the required behavior. For example, if we need to only update the cache with the return value of the method, we're better off implementing an after returning advice than an around advice. Also, an around advice can accomplish the same thing. Using the more specific advice type provides a simpler programming model with less potential for errors.